Quadratic equations and parabolas. A basic introduction to quadratic equations is that the equation starts as y equals x squared. Your highest power of x is going to be a squared power. Typically you have y on the left, sometimes you have f of x. Right. That's a quadratic equation. Now when a quadratic equation is graphed, it's actually this U shape called a parabola. It's U-shaped because when we square positive and negative values, they both end up positive. Over on the left, I've taken the equation y equals x squared, created a table of values for it. This is called a t-table. And you'll notice in this table, I have a column for x and a column for y. What I did is I selected strategically the values for x. I like to pick mine in order from -3 usually, to -2, -1, 0, 1, 2, 3. So they're in numerical order. Then when I have my values, I take each value. So let's say we have y, we have x is -3. So the equation would be y equals, instead of x squared, it would be -3 squared. And notice the -3 is all being squared, so this changes to +9. That's where the y value of 9 appears. Then I take that same equation, y equals x squared, and this time I substitute in a x value of -2, square it to get 4. Okay, so you can see that the y values are 9, 4, 1, 0, 1, 4, 9. When I plot those values on a graph, -3, 9, -2, 4, -1, 1, 0, 0, +1, +1, +2, +4, and +3, +9. So all my points are plotted, and then I draw a line through those, making the parabola shape. Two things to notice are these vocabulary terms: vertex. A vertex is the bottom of the parabola, or if the parabola were the other way, it would be the top of the parabola. The vertex here is the ordered pair 0, 0 because it passes through the origin right there at 0, 0. Axis of symmetry. Axis of symmetry is a vertical line that goes right down the middle of the parabola. It passes through the vertex, and with symmetry, the left side will look visibly the same as the right side, and that's what the line of symmetry here is, or the axis of symmetry. The equation always starts with x equals, and in this case it's 0. You always take the value from your vertex where x is, and that is what x equals for your axis of symmetry. It's a vertical line passing through the x value of 0. Okay, to take this a little bit further, the way that we graph a quadratic equation with a table of values is first you make a table of values and you strategically select x values that are sequential, so a pattern in the y values is noticeable. Then you calculate the y values, and lastly you plot the ordered pairs. So let's take the example y equals x squared plus 2x plus 3. If I substitute in this strategic x value of -3, then I would have -3 squared plus 2 times -3 plus 3. And this ends up giving me 9 minus 6 plus 3. So it gives me 6. That means the y value is 6. Earlier I had done the arithmetic for these values. And I have -2, 3. As my next ordered pair, -1, 2, 0, 3, 1, 6, 2, 11, and 3, 18. So in my table over on the left, I could put those values in. Remember, I had done the arithmetic for this earlier, so I found these values by one at a time taking each x value, let's say -2, plugging it into the x values of the equation and finding out with the order of operations what the y value was. Okay, over on the graph, I plotted those points. And if I move the graph a little bit, you can see that the points are sometimes way up there. The ones that I want to focus in on are the ones that have a vertex, the lowest point, and then have some symmetry going on with them. So I want to connect these, and I can do that if I type in our equation. We would have y equals x squared plus 2x plus 3. And see that the line, or the quadratic line, which is a parabola, passes through those points.